All right. Well, as I've been introduced, I'm Sam Morrow. I've been at GitHub for about 4 years at this point, just over, and I've been the lead developer of the GitHub MCP server basically since we created the repo. Um, I'm going to talk a bit about uh, a story of kind of how building it's gone and like where it's going, and I'm particularly going to focus on the problems and solutions that we kind of found along the way. I think that's probably the most interesting part of the story. And also, I was just curious if anyone wants to share. If you post, if you build stuff with MCP servers, then I'd love you to put it in the chat just so I can scroll back through afterwards and see what you guys are building. Um, so yeah, just going to walk you through the story of building GitHub MCP, and then yeah, please interrupt me if you've got questions. So, as most of you probably know, Anthropic launched the protocol in November last year, and they had a whole bunch of reference servers, including one for GitHub that they had built, and it was very popular. So, we spoke to them and we ended up asking if we could build our own version and take ownership, and they were delighted because that's exactly kind of what they envisaged, was that people would be obviously building and shipping their own. So yeah, they agreed, and we chose Golang because it's a solid language for efficiency and for building kind of production web services. And certainly there's plenty of Golang knowledge inside GitHub. So then, yeah, we finally launched our local stand.io server publicly. And this is just shows some example tools and things in VS Code agent mode, which it so happened that we launched our open source repo on the same day as the GA of agent mode. Tobin, question?
Yeah, I don't know if you want me to interrupt, but I have questions just to keep things fresh. You're using Golang. How do you feel about the Golang SDK as part of these decisions to build it early? This was one of the least supported SDKs for MCP. Just
You know
throwing you
what?
hardballs immediately.
No, 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 that's not a hard ball, but I'm actually going to say I will mention the Go SDK. So I'm just gonna tease that I promise we will cover
Amazing.
it. But yeah, I mean, so I guess an important note to that is we started at this stage with the community built MCP Go repo, which was not an official SDK. And yeah, I mean, I could see how people might find that an interesting choice, like when, for instance, TypeScript and C Sharp were quite popular SDKs and had official support already. But anyway, we just decided to go with Golang, and we haven't regretted it. But yeah, at the time there was no official SDK, and yeah, it was super exciting actually. There was a real buzz, and like once we launched, I was suddenly getting asked to talk about it on live streams and things. And I was doing trainings for like building your own servers inside GitHub, stuff like that to kind of get people onboarded. There was just a real buzz in the industry, and our launch was super well received. So we were actually the most starred repo on all of GitHub for the week we open sourced. And the stat I'm most excited about is that today we've got more than 3,000 forks. So people obviously are building all sorts of stuff with this, some of which they contribute back. But I think, like, I'm very curious. I don't have time to see all 3,000 and see what people have done. But yeah, and yeah, so issues and PRs, they were coming in really fast, and people wanted to use kind of features that didn't have tools and stuff yet. So it was both amazing, but it was also overwhelming. And we were trying to keep pace, keep merging stuff, and run experiments, and try to give users all the tools they wanted to add. Um, and success also came with its own challenges. So many people have probably heard of Simon Willison's lethal trifecta concept. And then, yeah, Invariant Labs came out with this post which made a big splash about a possible way of doing exfil attacks using that. And it actually would have been applicable to almost all MCP servers that can do a bunch of useful stuff. But they specifically called out GitHub, which was a great PR move for them because it got a lot of traction, and so respect where it's due. But it also opened some interesting conversations internally. So we For example, like it was one of the catalysts that got me to speak to our secret scanning team and start at least preventing token exfiltration through our MCP server. And that's just that on, you can't turn it off. So if it tries to send a token to a public repo or something like that, it will just block it from happening. But yeah, like there's not really much you can do about this. I mean, for example, if you have a logged in GHCLI in your bash environment, it can do more than the GitHub MCP server can do in terms of dangerous endpoints. Like it can control SSH keys and things like that. I think you've got to ask yourself, what do you want to allow users to do, and what do you want to completely prevent them from doing? Like we have a read-only mode, and also you can run things inside of a sandbox or limit the available tools. Um, and you can also obviously you can also use manual tool call approvals. So I wanted to mostly leave it up to end users to use their own uh, kind of smarts to basically decide what level of security risk they're willing to accept while we continue to evolve and find new ways to kind of offer it out of the box. But yeah, this was both a shock, but also in a way unsurprising. Like we knew about the potential for prompt injections and things like that. Uh, and yeah, I was working on a dynamic tool selection feature and the concept of tool sets we added in parallel. So what I wanted was that users could access all of our functionality while exposing only a subset of tools. And dynamic tool selection allowed you to start the server with only the tools required to search for and enable tool sets. And actually, in April, I also prototyped a version using RAG, which was ultimately never released, but um, it did help. Like the reason it wasn't released was more to do with feeling like it should be implemented by clients rather than a single MCP server. But yeah, we just wanted people to be able to scale out all sorts of workflows. But importantly, I was hoping that users would use this to subset the available tools to avoid context bloat and tool confusion problems. But what do you think happened? Everybody uses the default settings, and almost nobody, customizes the configuration, even if it's only a sort of couple of minutes work. Uh, and so this was a real UX problem. But at the same time, like we couldn't easily fix it without reducing functionality or developing much smarter solutions. Um, and things that complicate having really compound tools include the annotations in the MCP spec, where if I want to mark a tool as read only, it can be seen as safer by a client application. But if I try to combine read and write tools, currently the spec has nothing to support that. I just have to say that it's a write tool. And for example, in VS Code, that would then prompt the user to approve it by default. So like it's hard it's a harder problem to solve than it sounds for such a large platform. So to frame it with this AI generated image with very questionable icon choices, this is just, to kind of highlight how atomic tools offer complete compositional freedom at the cost of more context usage and more tool confusion. But it gets worse as the number of tools grow. Whereas conversely, if you make tools that wrap broader workflows, they can be much more effective and much less wasteful for tasks they're designed for. But they also cannot help with tasks they're not designed for. So, like a great example is say something like Sentry's MCP, where they build a great server, but also their platform has a smaller surface area, and finding, fixing, and managing errors like are great opportunities for kind of workflow based tools. And I'm not diminishing their work because they've put a lot of thought into the MCP interface they expose. But I feel like with the number of things you can do on GitHub, the problem kind of keeps like scaling to becoming difficult to solve if you want to enable everything. So anyway, like this is something we've thought about a lot, and I've taken in a lot of opinions from community and from blogs and things as well. And we do see a lot that people say, and yeah, we'll explore some solutions in a bit. But I wanted to highlight it was June when we launched our remote server. And suddenly it was a really easy installation story, no local runtime, no Docker images, and like it's very hard to get people to think about, oh, I need to pull the latest version of a Docker image to update the MCP server I'm using. So it also led to, before people had out of date things. Um, and yeah, like we worked hard to get a horizontally scalable stateful MCP server with stats and monitoring in Datadog, logs in Splunk, error reporting in Sentry, and also avoiding logging personally identifiable information. So, it's kind of a tightrope walk of getting enough logging and instrumentation into the server and adding hooks in places we need them, while also not just logging everything blindly. And that's something we take super seriously. Uh, and yeah, the open source server we use as a library for the remote server. And the code in the private remote server repo is almost entirely like customized Kubernetes config, logging stack, and authenticate. It's all stuff to do with hosting a server. But yeah, VS, the one problem we had was that while we support OAuth, GitHub wasn't really in a position to build out and support dynamic client registration. Like we're a major OAuth provider, so actually like changing how we register applications and things like that, it's not something we can change overnight. And just for the MCP server is a big ask. Um, so unfortunately, even with the upcoming OAuth client ID metadata spec, it's still not going to be trivial for us. So I'm confident we'll find a solution eventually, but yeah, anyway, that's a pain point. And yeah, this is another Gemini generated image with extremely questionable icons and a terrible GitHub logo. But the um the main connections here are clear. I just wanted to highlight kind of the rough architecture that hits our load balancer, and then the requests all go to a bunch of MCP servers, and we use Redis to store the sessions. And this is really important because uh, the initialize call, which happens asynchronously, furnishes a bunch of information, and also you have the session ID. So eventually we can make sure that all requests are using the right version of the SDK and that we understand they're part of the same session and these sorts of things, which also helps our logging and understanding user journeys and things too. But um, that's something that really wasn't well supported in SDKs, and so we had to do a lot of extra work. Um, but yeah, it's also a reason why when we get asked why we don't support streamable HTTP in the like our local open source server, it's because we put loads of work into this. And for example, if we're gonna do one for a GitHub Enterprise server, it's gonna have to be one that we can actually support, which means meaningful logs in the support bundles and that sort of thing. So it's not trivial. Um, and like another interesting quirk is that because it's not a one-to-one mapping of kind of agent to server like the local servers are normally used, we create a new server in the SDK sense every single request, and we dynamically build the set of tools based on things like the URL. You can use our tool sets with URLs or slash read only as well. Um, and also we can do feature flag experiments so we can try out new tools and things. And basically every request, we just build new server, supply the tools, and then the server you get like is kind of not an illusion, but it's entirely constructed at kind of request time, which I think is cool and enables us to also like experiment with internal clients and things for stuff we're not ready to release. So briefly, how's it going? Um,
Wait, can I ask? So that sounds like an enormous amount of work on top of the core SDKs. And so I'm curious to what extent, like that, all the load balancing management, this kind of like dynamically, like just in time spinning up of the server for calls. I don't see this in most of the way, at least the specs, the SDKs that I work with. How much additional engineering work did you put on top of these SDKs? To what extent is that open? To what extent do you even recommend people using this potentially Frankenstein system that you've designed? Do you regret those choices? I mean, you're going to do the how's it going, but I'm curious to hear more about all that.
No, no. So interestingly, the Go SDK has a more compositional approach, at least, which makes sense for building a server per request, and that's actually more how they envisaged it when the Google team was starting to work on that, which uh, I was happy about hearing because, they were, by the time they were building the Go SDK, remote servers were already a serious thing. And so I think the problems that people were facing were more clear. But like this is one of them, which is that you just oh, sorry, I should also add, we actually, in order to get the authentication layer stood up at first, we also had to have a forwarder through our our ingress facing layer. So we used a service that also hosts like Copilot kind of model APIs and stuff. But the consequence of that is that they do not have session affinity. So even if it would have been possible to use session affinity, so generally people hit the same server, by being forwarded through a service that doesn't, that would have been a fundamental impossibility. So uh, yeah, I wouldn't. I don't think we've got an easy framework to share. But what I would say, and I really will try to think about what can actually make it into SDKs in the future. But um, it what a lot of the authentication and a lot of kind of stuff when you're on a large scale infra just can't really be fitted into the inside of the SDK very well. So unfortunately, I think like it's hard to fully generalize. Um, so yeah, like I wish I had something I could just share, like use this pattern, this is sweet. But it's like even things like feature flags, like if your company uses feature flags, which I highly recommend, then building servers based on the request user, the URL, things like that allows you to ship fast. And it could also allow you could, by using the path matching, you can also deliver like 20 different MCP servers or an infinite number using exactly the same infrastructure, which is another like valuable thing from our side. And we currently don't leverage that much externally, but like I say, we do offer some different tools for some internal products and things. So yeah,
By the way, I wanted to mention the architecture diagram you showed. It looked like it's so funny because it looks like it's from the 90s, even though we're talking about like some of the most sophisticated tech available right now for AI engineers.
you know what? And I'm a fun fact. I that was not lost on me when I was hitting the generate button, but how it was the only one. I tried like about 16 different images. It was the only one from Gemini that was close enough to the actual arrows pointing
Architecture.
the right way that so I ended up sucking it up and accepting an image that looked that
I
dated.
love it. You should ship that as the official docs.
I also kind of, it was a challenge to myself also to see if I could get some useful images out of the
Yeah.
Gemini generator because like, I don't know, like I think everyone here has that sort of joy in that it's not quite working, but it's so close. Like, let's see what we can make it do and can we make it do serious things? And like the answer is increasingly yes, especially with coding, but like
Yeah.
yeah. I feel like for professional slide image generation, it's still lacking a little. So I hope you enjoy the rough and ready. Um, yeah, and so like to answer one of the questions earlier about kind of tool confusion and how we've addressed it, like the first thing is we wanted to do it right, and that meant building evals. So this is just a shot from an actions run from our Copilot offline eval framework. Um, but there's I can't share. There's loads of output, so I can't really even share a single output from it. But we basically have a whole bunch of prompts and expected tool calls, and we can just run this on arbitrary versions of the server remote and the open source server. And as we make changes to our tool offering, we try to do it more scientifically moving forward. And this delayed us a lot in terms of like sorting out the tools because we wanted to clean up the available tools first. Sorry, I mean, we wanted to be able to clean it up without breaking stuff first. So once we built out the remote server properly and the scaling of that was working well, and we built out evals, then the next thing was kind of okay, what can we do to improve the tools? And so one of the first things we did was use the analytics from the remote server to see exactly which tools are the most popular. And we now have a default tool set. So we don't expose all tools by default, but we do expose all the kind of obvious ones. And you can tell they're obvious because they're also the most widely used. So if you want some of our more niche tools, you have to actually specify the tool sets that you want to use. And the tool sets, we're still waiting for some kind of grouping to actually drop into the MCP spec because uh, there's been repeated attempts to bring something like that into the specification, but thus far they never have. And so we've just overlaid this concept and kind of ran with it. But I would really love to not do that and to do something that's kind of supported because then clients could support it too. Whereas now, like, and I think that might allow us to offer ones that people don't have enabled dynamically one day, which is also like much more the kind of UX I would imagine. Um, so yeah, I saw someone in the chat say now we've got roughly 40 tools. I think we've at least when we initially did this, we had 52 tools, and yeah, we more than halved the amount of tokens that the tool descriptions use. So that made a lot of people happy. But that wasn't all. We also did things like tool consolidation work. So like a good example is there were a bunch of different issues related read tools, and now there's a kind of issues read tool that wraps several of them. So I think roughly 40 tools is probably more accurate now because we managed to bring it down even further. And
Actually, Sam, while you're on that subject, Sebastian had asked in chat as well about API design for MCPs. So I'll read out the question and then maybe because this is relevant to what you're talking about, how do you choose which tools should exist and how much work a single tool should do? Uh, because I imagine like, it's not you're not just mapping the CRUD APIs on the GitHub API for like REST or something to MCP. How do you like bridge that divide between the MCP server API design and like a regular server API design?
yeah, that's kind of the golden question, I think, because what I would like to do, if possible, always is support workflows. And like what we're using agents for is kind of achieving specific tasks. So if possible, I would rather have the MCP tools kind of assist with a higher level goal. Like an example, like the actions tools we merged, but we merged them prematurely in my book. It was just people really wanted them, so I we also didn't want to hold back when there was code ready to go. But like, right, do you want to parse an actions log for a failed CI run in your agent's context window? Like, it's a resounding no. Some of them can be like megabytes of text. There's just have walls of text output. Like, what do you want? You actually want things like what failed and why, and those are the kind of that's the direction of travel is making things smarter and trying to make tools actually do not just return the kind of API result, but like give some kind of useful result from the data. Uh, and there's also been experiments like people may have seen the Cloudflare blog, but uh, so in instead of having more powerful workflow tools, there's also like an alternative of having code generation run against more atomic tools and kind of pipeline them itself so that instead of instead of calling all the MCP tools directly, like telling the model to write a script that can pipeline like 20
Mm.
calls or loop through something.
That's like code gen as a tool, basically,
Yeah.
which is code mode. I think that's what you're referring to from the
Yeah,
Cloudflare blog, right? Yeah.
yeah, exactly. And I
Yeah.
think like these concepts are only going to increase. Like if I have one kind of general ask to the community, it's like play with more adventurous clients, like build weird clients that have a slightly kind of unusual take. And I think we'll find the best value for agents and MCP will converge with clients that somehow leverage it in a better way than just putting all the tools into the context all of the time. Like I don't
That
believe that's the future.
Absolutely. That's such I've heard there are some services that will like have projected like thousands of tools possible. And in that case, like think of like, a cloud platform or something and all the different services that you can interact with and an MCP server for that. It's like a crazy proposition. It's impossible to do with today's like context windows anyway. One of the things I want to do actually is I think there's so many questions. I also wrote like 10 questions while you were talking, Sam, but maybe we can have Tobin present as well, and then we can circle back on a lot of these questions towards the end because I think a lot of the stuff that Tobin you're going to talk about is also going to touch on some of the things that I imagine folks have questions about. How does that sound?
That sounds good. And like I'm basically done anyway. There was one question from Tobin that I kind of covered here, which was that we're currently in the process of migrating to the Go SDK. This is literally happening now, and we're using a custom agent definition with Copilot coding agent that one of my team members wrote to try and automate the process of getting each tool set kind of moved across to the new SDK. And it's a big process, but yeah, at some point very soon we'll just do a hard cut over and then we'll be on the Go SDK, hopefully for live, and then hopefully we'll get all the new features faster.
Let's
Uh,
hope.
Amazing.
Let's hope. Who's maintaining that Go SDK? Is that still Google
it's
or
yeah, there's a couple of guys from Google are still the main maintainers. That's
Wow.
it.
amazing?
Like there's two of them really that are super engaged, and they actually even offered to do some code review for our because a lot of people look at it and it's one of the like it is I think the most popular Go server by a significant margin. So like it's important that prior art represents what they actually wanted out of the SDK. So I hope we can get
Mm.
there. So yeah, this was it. Like the last slide, I just wanted to say like as a team, we're always doing experiments. We're always having fun, like trying things and like trying like I say, like weird solutions to problems. Looking for kind of what's coming and we've looked at code gen for MCP, agent to agent, like more advanced forms of dynamic tool selection, tools that use models to achieve more complex goals, loads of stuff like that. But it's also an open source project, and I've shared my story with you. And what I would absolutely love is if people have opinionated takes or want to make changes to our server, like regardless of whether we accept a PR or not uh, like if you can help kind of change the way we think about delivering GitHub via MCP, that's amazing. So please, contributions are welcome, and yeah, I would love you to share. So yeah, thank you very much.